The questions today are actually essentially here because they will assist majorly with solve, but also the emphasis for me is on the setting out and the drawing of diagrams when you're actually answering questions. Now, the first question, this question 12 comes from the methods paper in 2022. It's paper 2, and it's about the normal distribution. Now, my approach to doing normal distribution questions is with the students is always draw a diagram, always draw the normal distribution and record what they give you on the diagram. Now, my students are well aware that then what happens is if you want to know the area of the shaded region, you simply go to normal CDF. Now, what that would mean on the calculator was if we went to second distribution there, and if we were to go down to normal CDF, which is option 2, and select that. Now, the lower limit in this case is negative infinity, so we're going to leave that alone. The upper limit, however, in this case is 12,000. And the mean was 13,700. And the standard deviation is 3,400. Now, nice feature with the TI-84 plus CE is that the option then is to paste. So what you end up doing is pasting the formula into the calculate section of the calculator, and then of course if you press enter, it actually produces the answer 0.3085. Now, I encourage my students to give 4 decimal places in probability questions. If you're doing something tech active, just give 4 anyway, even though the question doesn't say anything about that. 4 will pretty much cover what you need. Now, when we go to question 2, the diagram is actually very similar in that, but all that happens is the shaded area is then known at 0.6. It's the value of x down here. It's the upper limit that's actually not known. Now, this can be done using inverse norm, which is probably fairly standard procedure. However, I wanted to illustrate that there's perhaps a simpler way from the point of view of understanding for many students. And certainly it was something that one of my students taught me last year. She said, no need to do it that way. So I'd actually said, well, okay, what do I do? And she said, go to math, which of course was she was saying, go to the numerical solver. So I went to the solver and she said, I can put it in. So you need the area to be 0.6. Excuse me. And what you then need is normal CDF, which of course is normal CDF is down here, and normal CDF was option 2. The lower limit was that. The upper limit was the unknown this time. So she suggested just put X there. The mean and the standard deviation was still all the same. So at that point I could just paste. And at that point, of course, it pasted into the equation solver. And so then to execute that, if we go into the solver, it says, okay, what do you want as your first guess for X? Well, I'm thinking the first guess for X is going to be what, 14,000 is going to be a good guess. I don't know, in fact, what it is, but it really doesn't matter. In this case, because it's searching from negative infinity to infinity, it's going to do whatever it can to find the answer, okay? But I'm inclined to pick something bigger than the mean anyway. That was certainly going to happen. Now, if I, calculate that, then it comes back and says, okay, it's 14,561. And at this stage, of course, I'm not giving decimal places because this is not a probability. This is actually a calculation of the distance in kilometers. And so in my answer, I'm putting kilometers. Okay, so that's pretty much it on that question. So no need for inverse norm actually in this situation. There are occasions where inverse norm is necessary, but certainly not in this one. And it's the diagram which gives the whole game away to the students. And I want to go on now to, if we quit out of that and go back to the question, we're now saying determine the line y equals mx. This question is an old question. It comes from sample paper that was brought out before the first 2020 paper was sat for. So it's old, and of course, the notice that it's actually worth 8 marks. That's unlikely to happen these days. They don't write questions that are worth 8 marks, because it's been seen that that's an issue. Also, if you look at the marking guide for this, it's actually written in half marks, which is even like it kind of means that it's almost out of 16. But anyway, the point is that it's an old question, and the marking scheme is certainly old. Okay. So if I could then go to, well, what is there to do here? Now, for me, always draw a diagram and draw a reasonably big diagram. Don't scribble. This is actually an important level of understanding in the question. So I'm putting the function in the calculator. So while my calculator doesn't call it f of x, I'm inclined to call it f of x because it makes it easier to talk about the function in the writing. So I drew the diagram. The calculator said the diagram looked like that. Well, I could have done it by hand, but it was certainly 0 to 2, which was the point. Then I'm drawing the line y equals mx in. I'm calling that point P because it may come in handy. The area of this region here, it seems to be what's on the go, either that region there or the region up the white region up the top here, but one of those two is going to be a half of the whole area. So, and then I could see that what was going to make a difference is to actually establish what this value was. So whereabouts is the point P? In which case I said, well, the coordinates of B would certainly be B, comma, f of B, because I'd already defined what I meant by f of x up there. So no need to keep saying, no need to write there 2b brackets 2 minus b. F of B covers the ground. Then, of course, because I needed the area to be a half, the area was equal to a half of the integral from 0 to 2 of the function. Now, because I'd put the function in my calculator, it was a straightforward process to actually establish that the answer was 1.3. So if I could just go into that, if we go back into y equals there and type in the function, so it would actually be 2x brackets to subtract x bracket, and then that's the function. So the function's in the calculator, and of course, when you graph it, it looks like that. The window's slightly crazy in this situation, but probably no need to adjust it because I know what I'm looking for. For some students, it would be smart to actually readjust the window, but I'm inclined not to here. Certainly, then it's a case of, can I do the integration? Now I have a couple of choices here, although my preferred option is to quit out of this and do it on the calculate section because I need to find a half of the answer. So I'm inclined to say what I want here is a fraction. So I want 1 over 2. Then I want to do an integration. So I'm going to math and integrate is option 9. I'm going from 0 all the way to 2. And it's the function I want is f of x, although in my calculator it's y1. So I'm inclined to say if I go alpha f4, it offers me the functions that I have, well, not functions that I have, but the function menu, and it's dx that I want. So then if I execute that, it comes back and says, okay, the area of the shaded region, A, should actually be 1.333. So 1.3 recurring. So I'm recording that there. Now, if you read the marking guide, you'll notice that it actually does the integration, whereas the question seems, well, it's a TEC active question, and there's no evidence in this that I shouldn't be using my calculator for whatever I see to do. So that integration and the halving could all happen in one step, although there's a temptation to say you should find one and then the other. But in reality, no, this is what needs to happen. I then went on and said, okay, now I could have addressed the white area or the bottom area. Now I have the benefit of hindsight in this, and I realized that it was simpler if you actually treated the bottom area. It was simpler to do. Students weren't to know that, they were going to do whatever they did. But for me, the area of A was certainly this triangle, which I pretty much just drew. And then I said, and I'm trying to integrate from b to 2 of the function. Well, that's all good. Then I did make a note on the side here that the area of a triangle is equal to half the base times the height. Now, that's pretty obvious, that one, except that so I picked up on Facebook here a while back. Ben Grenfield actually said, be gentle with the marker. So if you're doing something that is not necessarily simple to see, then say what you're doing. And that's why I'm also writing f of x, because I set up the top here what it is, and so it's straightforward for the marker to see what I'm doing. I then went on and said, okay, the base of the triangle is b and the height of the triangle is f of b. So I was just able to put that in. And I just put ditto marks there because I didn't want to write it again. And then, of course, I'm saying 1.3 recurring should be equal to that. And then I just went straight to the solver. Now I'm putting solve in brackets, not because it's really to be gentle to the marker, so the marker knows what I did. And it came back with b being equal to 1.587. That made things very easy because at the point P up here, so I said what P was, at this point here, f of b should equal m times b. And of course, m is the gradient that I'm looking for. And since that's the case, I can solve that, and m is equal to 0.825. That means the equation is y is approximately 0.825x. Now, if you read the marking guide says that the answer is the cube root of 4. Which is correct. It is. There's no doubt about that. Although there's no indication in the question that necessarily an exact value should be sought. So being a tech active paper, I'm inclined to say, well, then let's just go for it and see what the calculator can do here. Now, in terms of establishing the reasonableness, it was very straightforward at this point to establish the reasonableness, because it was going to be reasonable if the white area was in fact equal to the same thing. So if I then turned around and said, okay, if I integrate from 0, which is here, to b, so we integrate from 0 to b, of the top function minus the bottom function. Now I don't need to worry about m. M is actually in my calculator as m, so when I'm actually solving or when I'm executing this, it will actually do it. Now I want to actually go to doing the whole question then on the calculator. So if we clear that out, and now let's just see. So in the function, we've got the function there. Yes, that's okay. Now, if I then go to the numeric solver, because I'm actually wanting to execute it, well, here, of course, I'm putting in 1.3 recurring. I just go a little bit crazy with the 3's. That makes it easier than doing anything else. Delete that and start again. And I'm after a fraction, which I could do as 0.5, and I'm inclined to, just because it's easier to type that rather than use the fraction. 0.5, and it's alpha, so it'll be alpha b. So I want b to be multiplied by f of b, which of course is alpha f4. And to execute that, if I put brackets, alpha b, it's now calculating the value of using the function of what happens when you put b there. So it's calculating f of b. Then I'm saying I want an integration, so I'm going back to math again and selecting the option 9, which is to integrate. I'm going from b, so it's alpha b, up to 2, and it's the function that I'm integrating. So again, it's alpha f4, y1, and it's dx. So at that point, if we execute, it says, okay, b is 0. B is the thing I'm looking for, so I'm inclined to leave it on there. I know b is not 0. I'm inclined to just put in 1. I can put in pretty much whatever I want there, but I'm inclined to choose a value which is at least reasonable, or at least in the ball game. And since B is going to be a number between 0 and 2, that's a good choice. And then if I execute that, it comes back and says, okay, B is 1.587. And again, that sounds reasonable under the circumstances. I could check it out if I needed to, but no need. Now, if we quit out of that, then B is available to us. It's 1.587. Now, then my solution went on to say, and f of B is equal to MB. Now, I could go to the solver at that stage, and I pretended that I had gone to the solver by writing solve. In fact, I didn't do that. What I actually did was did it as a division. So I went to, so I said alpha F4 Y1 of B. So it was alpha B, and I divided that by B because that was essentially what I needed to do. And comes back and says, okay, the value of M is 0.825. So that was the answer to the question. So the question was asking for the equation y equals 0.825x. Now, this again was reasonable. Now, here I could pretend I'd done that, and it's accurate. If that integration is in fact equal to 1.3, then that's what there is to do. All right, then it is reasonable. And when I first did this question, I made a mistake in the calculations. And so when I actually did that, it didn't come out as 1.3, which of course, just as well, I didn't just assume it was going to be right. Now, all I need to do here then is to go back in and say, all right, I need to do an integration, which is option 9. I'm integrating from 0 to B. So that'll be alpha B, and it's the y1 function that we had, so it's alpha y1. So that function is being integrated, and I'm subtracting from that the answer, which is in the line above. So I could just put there answer. So answer, and then put, let's just see, and then x dx, and execute that. Comes out as 1.33. So that was correct. So at that point, so again with this question, without it flagging that I had to find an exact value, then this is my anticipated answer. I'm saying, okay, that's what the question could we reasonably expect me to do. I know there's a trend or a kind of a tendency for people to now say, give exact values. It's a little bit unfortunate that that's happening, because it means then that students are not having their muscles flexed around the calculator. If you set questions where you say, give the exact value or certain things like that, you're essentially saying, do the question tech-free. Now, it's a little bit unfortunate, given it's a tech-active paper, that you would turn around and say, but this one do tech-free. But there could be more said about that later. Okay, so I'm done on that. That's the end of that. So if I stop sharing there and stop the recording.